Microphone printed circuit board thermal analysis. Printed circuit board is made of dielectric medium. There are some copper tracks and some elements soldered to the board. The currents and the power consumption are known values, so there is no need to run electric analysis. Our task is to calculate the temperature distribution. I will start QuickField now. In QuickField I create new problem. PCB mic. Next. Problem type is steady state heat transfer. Model class is 3-dimensional import and length units are millimeters. Finish. On the left you can see the problem pane and on the right you can see the geometry model editor window. I will import the geometry model from the step file. Step file is used by the majority of the CAD systems to interchange 3-dimensional geometric models. So here is the file. Open. Now the model is imported and here I should assign labels. Through labels I will specify material properties. Click here. The face is selected. To select a body you should click the selected face again. Now the body is selected and this is the dielectric board. Okay, click to select the face, second click to select the body. This is the chip. Click, second click, this is the microphone. Click, second click, this is the capacitor. C1. Click, second click. To select multiple objects at the same time, hold the Ctrl button pressed. Click here, so 2 bodies are selected. 2 bodies. These are made of plastic PVC. This is resistor R1. This is resistor R2. This is a resistor R3. And here is the resistor R4. Now we should specify physical properties for each label. The board is made of dielectric medium with the thermal conductivity of 0.3 watts per Kelvin meter. Okay. Plastic thermal conductivity is 3 watts per Kelvin meter. Chip thermal conductivity is 1, and here I should specify volume power. Power is given, it is 0.1 watts, and now I should divide it by the volume. Let me check. I select the chip and here I can see that the volume is 126 millimeters cubed. Chip thermal conductivity 1, power 0.1 watts divided by the volume millimeters cubed. This would be meters cubed. Okay. The same way I proceed with the other labels. Volume of the capacitor is 63 millimeters cubed and the losses in the capacitor is 10 milliwatts divided by the volume converted to the meters cubed. Okay. Microphone. This is the volume and the losses are the same, 10 milliwatts. Thermal conductivity is 1. 10 milliwatts divided by the volume. Okay. The same for the resistors. This is the volume. For resistors I will use more complicated formula. I know the current, which is 0.1 amperes. Square this value, multiply by the resistance value, 1 ohm. This would be the power. Now I divide the power by the volume. Times 10 to the power of minus 9 to convert from millimeters cubed to meters cubed. All other resistors has the same value of 1 ohm and the same current, so I can copy this and assign for all other resistors. Thermal conductivity 1 and the volume power, thermal conductivity 1 and the volume power. Okay, that's for the board and circuit elements, but here we have the conductors. Let's hide the board. Let's hide the plastic. Let's hide the microphone. Now these and these are conductors. Conductors are made of copper with thermal conductivity of 380 watts per Kelvin meter. Okay. Now I have labeled all bodies and should assign labels to boundaries. We assume natural convection condition on all faces. So right click and select everything, and for the faces I assign the label convection. For this label I specify convection coefficient, which is 5, and the ambient air temperature, which is plus 20 degrees Celsius. Okay. In fact, convection condition should be assigned to the free faces only. I shouldn't assign convection condition to the contact faces. So I will hide the board and select the contacted faces only. Right click. Now you see the contacted faces are selected, and for these faces I should remove the convection condition label. None. Now I can unhide all. Before I start the analysis, I should build the finite element mesh. Just click this button in series. First I build the mesh for edges, then I build the mesh for faces, and the last I build the mesh in volumes. Now save all simulation files and run the analysis. The problem has been solved, and we can take a look at the results now. Here you can see the color plot of the temperature distribution. You can get the exact temperature value at any point. Just use the probing tool, click the point, and here is the temperature. Or you can also specify the coordinates manually. You can choose between different presentation types, use the cut by plane tool, switch on the easy surface plot. You can adjust the step, and you can see the cross section in a separate window. Here again you can choose the presentation method, switch on the heat flux, measure the temperature in any point, or use the contour tool to get the temperature distribution along some line. Or you can see the field data in the table. If you search for the PCB microphone thermal analysis, you will find the example page on our website. Here you can read about problem setup, browse for the solution section, take a look at the results, and download the simulation files. Simulation files may be viewed using any QuickField edition, including free QuickField Student Edition.